Okay, cool. Well, welcome everyone. And I'm Anouk today. I'm a product owner at UbiOps, and I'm going to talk to you a little bit about running AI at scale in a hybrid cloud setting. And I'll do that with the use of an interactive example that you can either follow along with me, or you can just watch me do it and maybe try it out later yourself. So as I mentioned, I'm working for UbiOps. Now, you might know us, you might not. I figured it might be good to just do a little introduction of who we are before we start. So basically, UbiOps is an MLOps platform made for running and scaling AI and ML workloads. So we're really designed for data scientists to work with us without having like the steep learning curve of a tool like Kubernetes. To really make sure that a data scientist can take ownership of their models and also make sure that they can go to production. So without further ado, this is the schedule I had in mind for today. So I only have got 30 minutes, so I'm going to try to squash everything in there. Introduction we already had. I'm going to talk a little bit about model serving in production and what does this mean, some common pitfalls that I see. And afterwards, we're just going to have a little workshop. I'm going to deploy a computer vision model with you. And we're going to do that live. And after we've done that, I will also touch upon a little bit how would this work in a hybrid cloud setup. So what would be different and what would be the same. And afterwards, we can have a little Q&A. If I finish a bit early, I think we can have some like in the comment section that I can answer here already. And otherwise, I will be available on the Arize Slack to go over all your questions there as well. So let's talk about bringing machine learning to production, or as I like to call it, getting machine learning from the lab to the field. Because when you're a data scientist and you start working on a model, you've got a model task that you need to make, then typically this is on your local laptop, maybe in a notebook environment or writing Python code directly. But at some point, this, of course, needs to start generating value for a business. And there's a path between these two, like something that's locally on your laptop doesn't necessarily provide value straight away. So to do that, surprisingly, I get the question quite often what the issue is with just keeping code locally. And obviously, there are quite a few obstacles with keeping code locally. Now, some use cases, it might be fine to run something yourself manually every month. But for a lot of use cases, you need to really move it to a production environment. An example where you need this is when we look at access to the necessary data, because typically as a data scientist, you only get a subset of the production data to work on for developing your model. But when your model needs to move to production, it needs to have access to the actual production data. And this might have a big impact on your model as well. And does your laptop have access to that? Then there's a reliability piece. If it's locally on your laptop, a laptop might crash. So what if you have a model that needs to run like 24/7? But also resources. What if you don't have a powerful enough GPU for what you need to run? All of those things come together to create this issue of needing to deploy your machine learning model or your code to a production environment that can handle these obstacles. Now, typically the plan that I see from companies looks something like this. So we just have a data scientist developing code. We're putting that in some kind of Jupyter environment. Maybe at some point we put it inside a Docker container and then we put it on the cloud and poof, we're done. Now, as some of you might recognize, I see that very often the path actually looks something like this. So there are so many different tools in this MLOps landscape that all start coming together, that all need to be connected to actually get from something that you wrote on your laptop to something that's actually providing value. And a lot of these tools have a very steep learning curve, are created for software engineers and not necessarily for data scientists. And it can just be quite a tricky road to cross. So what we try to do is to focus really on going from a code to a live app in a couple of simple steps. And that's also what we're going to do today. So maybe to put that in a little bit of context, I wanted to go through an example case of Bayer, because this is basically the real life scenario of what we're going to do in a little bit. Because we're going to deploy a computer vision app together. And Bayer Crop Science did the exact same thing with us. They've got an app called Magic Scout, which is an app for farmers worldwide. And this allows farmers to take a picture of their crops, upload it to the app, and the app will tell them if their crops are healthy, if they've got pests or weeds, and it will also give them recommendations on how best to approach these problems that they might be having with their crops. So this is the setup essentially that they needed. They needed this end user, upload a picture, goes to the application, that mobile application sends this picture to the AI model that's hosted somewhere. The AI model will send a prediction back, and the application will show this result in a nice format to their end user, and then you've got a happy end user. And the thing they found out is that data science teams are really good at building great AI models, and their model worked really well. But the problem was that they were not necessarily that good at deploying and scaling them. So they've got the first part, but what happens when you've got all these farmers worldwide sending so many images to that model? Like, can that model then still also handle that? Like, maybe 1 per hour is fine, but what if it becomes hundreds per second? Can you then also scale it up? And this becomes an increasing issue when you're working with computer vision, because very often you need GPUs to be able to do this in a timely fashion. Especially here with a mobile application, you really need response time of like millisecond level, or at most a couple of seconds. Because if you're longer than that, then a user will start to get frustrated because they think that their app crashed, and that's of course not what you want. So basically what the issue here was that they needed to solve the challenge of deploying AI and no longer the challenge of making AI models. And this is because all of a sudden you start entering this IT world that you have to deal with. So you have to make API endpoints, security and access control, monitoring, which is of course something you can very nicely do with Arize, resources. Do you have enough CPUs and GPUs? It's a whole different ballgame than making a nice model that works well. So what we did with them is basically they use UbiOps to host and to serve their models. So the model behind the Magic Scout app is running on an installation of UbiOps that runs both in Google Cloud and AWS for them. And by doing this, they make sure that they always have enough resources, because essentially when Google Cloud doesn't have enough GPUs anymore for the demand that their app has at that moment, we simply switch over to AWS and source GPUs from them. And this way they can really handle that peak traffic that they have, because their data traffic is also very seasonal. As you can imagine, farmers will be a lot more active in using this application in the summer than in the winter. So it's quite unpredictable also how much traffic they have. And by having this hybrid cloud setup with them, we managed to make sure that they always have enough resources. So it's workshop time. It's your turn now. If you want, of course, you're also more than welcome to just watch me do it and see how it works. So what are we going to build today? So we're going to build your own live prediction engine that runs in the cloud and can process data through an API. So we're going to take a pre-trained neural network for number detection based on the MNIST, which you might recognize. So I already prepared this for you. We're not going to train a model today. That's something different. And then afterwards, we're going to deploy the Python code to run this model on UbiOps. And that will look something like this. So we will have an image of a number, in this case it's a 5, that we can send to this API that's hosted on UbiOps. And this model will then send back an output of, this is a 5, I'm 96% sure, or this is a 4, I'm so many percent sure. So that's essentially what we're going to build. And the steps to do that are this. We're going to write some code, or actually I wrote some code for you that you can see how it works. We're going to deploy that, and then we're going to just send some data to the API so that you can see it in action. So let's get started. Here's what you need. If you want to follow along yourself, you will need a UbiOps account, which you can create at app.ubiops.com/signup. It's completely free. And secondly, we need a Google Colab notebook for deploying the model. So this is all the code that I already prepared. And you can find that either by going to this link or scanning the QR code. So that's how you can find it. Maggie also already put it in the chat, so there you can see it as well. So I'll leave this, or actually the link is in the chat. So let me just share my screen and switch over to the notebook, and then we can do that. let me actually first go to the web app so you can see where we go. I'll share my screen. Okay, perfect. You are seeing my screen now. Let's first go to the web app. So let me go full screen so you can see it hopefully a bit better, and I'll zoom in a little bit. Okay, so this is the UbiOps web app. If you create a new account and a new project, this is roughly what you will see, but probably with less data than mine. To run the notebook, you will need something that we call an API token, because this is used to authenticate so that you can speak to UbiOps through code using our client library instead of having to do everything through the web app, because we will do it through code. So if you need an API token, I'm just going to show you where you can make it, because I will also need one. You can head over to permissions, to API tokens, click add token. So I'm going to use this, or I'm going to give it a name, Arize observe token. And it's an expiration field as well. And then I can go to the next step. I can say what permissions this API token needs. For this case, we need project editor permissions. So I can give that. And then I will copy my token. And then we've got this token. And once you've got the token, you can head to the Google Colab. So let me go full screen. Okay. And then we can start. So when you open the Google Colab, you should be seeing this. So the workshop for Arize Observe, deploying a computer vision model to the cloud with UbiOps. So here you can see again the setup of what we're actually making. So let's just go through it. First things first, we need to install the UbiOps client library. So I already did this, so that this should work. But if you run it, you should see something like this. So just collecting UbiOps from PyPy, the latest version, it should be 3.15.1. And then everything should work. And then if we've got UbiOps installed, then we can continue to defining the project info and setting up a connection with UbiOps. So we're going to use that token that we made just now to basically authenticate ourselves. So if you run this cell, what you will see is you will see the little prompt where you can enter this token in a safe way. So I'm just going to paste my token here. And when I click enter, if everything went well, you should be receiving status OK. If you don't receive status OK, something went wrong, and it's probably with your token formatting. So make sure that your token is of the shape token space and then some kind of token code. And then you should have status OK. So now we've got this connection set up to UbiOps, which means that we can actually start doing something. We can start creating a deployment. So a deployment is basically an object within UbiOps that serves your code. So any kind of Python or R code. And this deployment has a defined input and output set. So in our case, what we're going to be sending is an input field that's called image, and this is of data type file. So we're going to be sending this image file. And as output, we will have a prediction, which is in this case of type string. And I also added a label so that you can easily see it back in the web app when you log in. So if we run this cell, then if everything goes right, you should see something like this, which is basically tells you the information of your deployment that was just created. Now, what we can also do is go back to the web app, go to deployments, and go full screen again. And here you should see something like this. So MNIST 2023 and today's date. So this is the one that we just created. As you can see, it has the right label, but there's nothing really here yet. That's because we still need to make that. So if we go back to the collab, go full screen again, we can continue. We can now actually start preparing our code, because every deployment can have multiple versions, and the versions contain the actual code implementation. The reason why this is split out is that if you create a new version with like a new implementation, but that performs the same action, so that still takes this input image and returns the prediction, but just with a different code implementation, you can just create a new version and your API endpoint doesn't change. So you don't have to update that. So we now still need to make our version. So first of all, let's make a directory called deployment package. I already actually have one, so that's why it's giving this error for me now. And once we've got this directory for a deployment package, we can start putting our code in there that we will deploy to UbiOps. Now I've got this write file statement, which will make sure that all the code in this cell will be written to a deployment.py file. So in this cell, you can see the actual code that will be run by UbiOps whenever it receives data. So here we're just importing Keras and image.io, nothing too special. And then you can see that we've got a class called deployment with two functions, an init function and a request function. The init function is run whenever deployment initializes on UbiOps. So this is basically the place where you would load things into main memory. And this is what we're doing here. Here you can see that I'm loading in the weights of my pre-trained model. So I've got a CNN.h5 file, which basically specifies how my neural network looks. And I'm just loading that in here so that that's ready whenever any data gets passed to this deployment instance. And then we've got the request function. The request function is the one that actually receives the input data and can process that to return our output data. So what you can see here on line 52 is that we read in this image file that we receive. So here we use the image field we retrieve from the data dictionary that's being passed to this function. And we're going to just convert it to the right format so that our model can actually work with it properly. And then we're going to call the predict function of our model, nothing too special there. And we're going to return the result of this is what number it is and how much percent sure we are. And that we will return in the return statement. So if you run this cell, then you should see something like this, like writing or overwriting deployment package / deployment.py. And this will mean that this file has now been written away to a Python file. And then we still need a requirements.txt because, as you can see, I import some packages. So to make sure that I have actually access to these packages on UbiOps as well, I need to pass a requirements.txt that specifies all the libraries that need to be installed for this deployment to function. So in my case, it's like Keras and TensorFlow. So when I run that, it will create a requirements.txt. And then the last thing we need for this to work is that weights file. Because in the init function, we're loading this CNN.h5 file, but we don't have that yet. So I've prepared that on our Google Cloud Storage. So with this curl command, you can download the CNN.h5 file locally, and it will put it in the right package so that now we've got a folder that contains 3 files, a deployment.py with the code to run, a requirements.txt with any packages that need to be installed, and the weights file that we need. Okay, so then all that's left to do is actually push this code to UbiOps and create a new version. So I can do that by running this cell. And in this cell, what you can see is here that we call UbiOps deployment version create. We made a version. This case, it's running Python 3.7. We specify the memory allocation, how much it can scale. And then we just pass that to our API to create it. And we zip this directory that we made with the code, and we also upload that to this version to make a new revision of that version that contains this actual code. So now the only thing that we need to do is wait until the deployment is actually ready for use, because it needs to be built for a little bit first. So if I run this function will wait for this deployment version to be ready. Mine might be a little bit quicker than yours because deployment build gets quicker if it uses an environment that you already use somewhere else in the project. So I've already installed like these packages very often, so the build time is very quick. If you do it for the first time with a requirements.txt file that you've never used before, or any different kind of packages that you use, then it might take a little bit longer, but it shouldn't take longer than a couple of minutes max for this one. And once that deployment is ready, so you should get that back from the function as well, you can actually send data to this model. Now we've prepared a couple of example images that you can use. So if you run this cell, you will retrieve them from our Google storage, and you can use these. Because then here we've got a little bit of like a tiny code snippet to just show you with one of the example images how it works. So this example image 2.jpg, if we load it, this is basically what it looks like. So it's a handwritten 2. And this we can upload to UbiOps and send to that model that we just deployed. Because if we now also go to UbiOps, we should see that that one is ready. So let me quickly reload. Yeah, and here we can see the version that we just made, version v1. If we go to it, we can see that it's available. The last build status was success. So now it's ready to accept input data. So let's go back to the collab and upload it. So we can upload the image to UbiOps, which we do with UbiOps utils upload file. This uploads it to a specific bucket in your project. And then we can use that file URI to make a request to our deployment. And making the request, so actually sending the data is what we do here. So with api.deployment request create, we just pass the project name, the deployment name, and what data we want to send with it. So in our case, that's this image that we wanted to process. And as you can see, gave back prediction. This is a 2. I am 100% sure of it. Now, if you want to try this with one of the other ones, you can simply change the file path that's here to one of the other ones. So for instance, we can do a 3 as well. So this is a 3. You can run that. And then we should get back prediction. This is a 3. I'm 99.93% sure. And that's basically it. We now deployed this computer vision model that we made to UbiOps, and it's accessible now through an API. So the nice thing is that with the use of an API token, this model can now be exposed to other services. So I now wrote this request like through with a Python client library here, but I could do the same from my terminal if I wanted to, or from a website. So if I've got a website, for instance, where I want to host some other kind of computer vision app where people can upload images and that image gets sent to a model, that would be the exact same setup, but then the website would make this request instead of us doing it through code here. So let me go back to the stream and share my slides again. Yeah, thank you, Maggie. So I mentioned in the beginning that I would also touch upon how this would work in a hybrid setup, because right now we deployed to our UbiOps SaaS platform, which is hosted on Google Cloud. But actually, we can also just deploy to other clouds if we want to. Because in UbiOps, we've got this option to be connected to multiple node pools while still using the same interface. So this is also what I mentioned what Bayer uses, for instance. So if you have our UbiOps core services, so just the SaaS at app.ubiops.com, what we can do is add additional node pools to your organization. For instance, one in AWS or even an on-premise cluster if you want, and connect them to your organization so that you have access to these other node pools that you can actually deploy on as well. And we've also got some that we offer out of the box if they're necessary. And the nice thing about this is that even though it will be hybrid cloud and you have multiple clouds, you can still have just one single unified interface, and essentially nothing changes in your workflow. The only thing that really changes is what kind of instance type you select. So when I made the deployment before, I selected an instance type with 2048 MB. If we have an instance that's in AWS, we would append it with the AWS suffix, for instance. So then instead of saying 2048 MB as instance type, I could say 2048 dash AWS, for instance, and deploy it there as long as your account has access to those. And in this way, you basically bring them together, and the only change is really what you can pick from a dropdown or what you send as a parameter while still being able to utilize these multiple cloud resources. Okay, and I think I see that I have a little bit of time, so let me just show you that as well. So I'll just share my screen again and show you how this works in the web app. Let's go there. Okay. think you should be able to see my tab. So let's just make it full screen as well, so it should be a bit more visible. So I've got here the version that we already made. Now I can also duplicate that version and now make a version that actually runs on AWS instead of Google. So what I can do is I will use the same deployment package, so the exact same code. I don't want to make changes there, but let's say I want to turn on a GPU this time. And so I'll do Python 3.7 with CUDA in there. And I'll go to the resource settings, and here you can see the NVIDIA Tesla T4, and this one's actually hosted on AWS. So now I can pick this one from the dropdown, and when I deploy this, it will be created in AWS once it's ready to be built. So now the revision is being made, and there we go. So this one's now actually hosted somewhere else. So it's no longer in Google. And that's really all it takes. So that's really the only difference there really is. Not really any difference in how you would create a deployment or how you would work with that. Of course, there's the difference of how you access the data, but also for that, we offer connecting your own storage buckets. So when you connect to your own storage bucket, you can select connect to existing cloud bucket and select which provider it is. So you can just connect a storage bucket you have in AWS and one in Google Cloud and work through it in the same way as we just did with the files. So also there, nothing really changes. Okay. And then I'm gonna wrap up. So I still have some key takeaways in the slides. If you can bring them back up, Maggie. Thank you. So my key takeaways for today are really think about how your infrastructure is going to scale in the early stages of development. Like, don't leave it till the last minute, because that's something that I really see happening a lot. And it's just a shame if you worked so hard as a data scientist on making this great model and the infrastructure is just not ready to actually put it in production. And oh, I see that there's a question. Let me check. So I see from Kelvin, how do you decide when a data/model is ready to be deployed? How do you make sure it won't break or run into issues when it's deployed? So that's a very good question. So something I really personally like doing here is actually deploying in shadow mode. So what you can do is basically run two models side by side, where one is actually connected to the output and the other is not, but you still log how it's performing. In UbiOps, we can do this with pipelines. So you basically can drag two deployments in there, run them side by side, but only connect one to the pipeline end. And that way you can monitor how this deployment is interacting with production data without actually any end user having any effects of this. Of course, you need to be careful here with your resources because it will require resources. So maybe it's nice to not do that for everything. But I think it's really helpful to sometimes just deploy something in shadow mode, see how it reacts, see if it performs the way you would expect. And if not, take it back down, iterate, and deploy it again in shadow mode until you think like, oh, this is actually better than the model I already had. Another way you can do this is with, or actually the formal way of doing this is by champion challenger models. So where you've got your champion that you really run in production and you've got a challenger model that you run in shadow mode, maybe even multiple. And if one of the challengers starts to consistently perform better than the current champion, you can promote them to champion and demote the champion to challenger. That's a setup that I personally really recommend working with, because I think it's very hard to get an estimate of how your model performs before you put it in production, because production data is inherently pretty different from historic data that you will train the model on. And then you can also immediately check if you run into issues when it's deployed. So I hope that answers your question. And I see another question from Alexander. How does UbiOps scale with load? So let me see if I understand this correctly. So basically, when you create a deployment, I kind of went over it now quickly, because in the notebook, you will see that there's a parameter called minimum number of instances, which we set to 0, and maximum to 1. This means that this deployment that we just made scales from 0 to 1, so it cannot really scale up. This is just to make sure that you won't eat through all your resources. But if you set that maximum number of instances to a higher number, you can scale up. And we do that automatically, and we do that based on the data traffic that's being sent to your model. So the more data you're sending to your model, the more instances we will start spinning up to accommodate that increase in data traffic. And when the data traffic slows down again, we will start scaling them down and turning off these instances so that it also scales back down to the minimum number of instances. And I see we're already at the time, so I will answer the rest in the Slack community. Here are my key takeaways still, and here shortly my contact information. Feel free to get in touch with me either through the Arize Slack community or email me directly. And yeah, thank you for listening, and I hope you have a lovely rest of the event.
Are live. Just get comments up here. Perfect. All right, everyone, thanks for joining. My name's Amber. I'm an ML growth lead here at Arize, and I'm going to be walking you through kind of the key things that I've seen help folks get that next role in tech. Let me just post. I do have a blog post out on the topics we're going to be going through, and I'm going to kind of walk through those and share, but I really like people to share their own journeys. I like these to be as collaborative as possible. And I think when all of us have tried to get our first role in tech, our first role out of grad school, we've attended talks, and there's always been kind of caveats of, oh, that doesn't relate to me. So I want to hear from you folks, and I really want to answer your questions. So my background, so I am an astronomer. And then after I got my master's in astronomy, I applied for a lot of different roles as a data scientist. Wasn't really sure what I was doing. I was sending out 3-page CVs and not hearing back. And then I joined a fellowship program at Insight Data Science, and it was the AI track for that program. And then after completing that program, I worked for Insight for about 2 years and ended up being the head of AI at Insight. And the key parts that we were doing is we were bringing in a lot of fellows, bringing in a lot of folks with different backgrounds, sometimes technical, sometimes non-technical, and helping train them to be data scientists, data engineers, and machine learning engineers. And throughout that process, I've really seen over 200 folks from different backgrounds, a variety of backgrounds, get roles as data scientists, as machine learning engineers, and as data engineers. And those key findings, I've been passing them along. I've had a lot of one-on-ones talking with new grads and just trying to help folks understand what the key things they need for getting that next role are. So I'm going to share screen just to show the paper. But again, I like these to be super interactive. I like to really dive into different parts of what people are struggling with to give them realistic answers and to give them actionable answers. So being able to walk through, what the problem is, how do we get to a solution? So in the piece I'm walking through, there's really 5 rules that I see. It being a numbers game, networking, folks saying it's not the right time, the change in environment, and then also just noting like everything is an interview. So before getting into this, and I'm sure there'll be questions on it, questions as we go through, I'm curious, like where are people at in their ML journey? Are there any folks here that are looking for their first role, that are looking for their next role, any particular roles that you're interested in? And then if there's any challenges that you've met along the way there. Okay, and I think I should be able to just see the chat, this channel. Okay, because I'm going to be constantly looking back at the chat. So just getting into the main rules I see. So the first is, and everything we're going to be covering here is from that first initial thought of I want to get a role in tech, I want to get a data science role or a machine learning engineering role, to the point of actually starting that role. I recommend attending Lacey's session as well, because while we'll mention negotiation and knowing self-worth, like she really will get into those topics. But if you have questions on negotiations, I can also answer those in there. So the first one being, it's a numbers game. And it seems like that should be obvious to someone that's analytical, someone that's applying for roles in tech. But the truth is, it's hard to kind of wrap your mind around, hey, I'm playing the numbers game, because you do get attached to these roles. There are ones you're very passionate about and ones that hurt if you get rejected or it doesn't go through. I also see we have a few people responding. So a data scientist looking for an ML focused role. That's a very, very popular one. Thanks, Calvin. Garrett saying he's looking for his next role, had previous tech and AI positions. And I know there's a lot of folks now that are looking at roles like prompt engineer and LLMops, and these roles that are just starting to come out, but are essentially the new data scientist and the new machine learning engineer. So thinking first that it's a numbers game, it really depends on the amount of applications that you're able to get out. Hearing from folks saying they're having trouble just getting interviews on the calendar. I tend to ask how many resumes they're sending out, and normally the answer is like 1 or 2 a week, which just isn't enough. Remember, you don't have to prepare for these interviews when you're sending in a resume. Understand why you want to work at the company, but I know some folks that will apply and they'll start even prepping before they hear any feedback back as well. So, make sure your applications are concise. You can have, I would say, a standard cover letter, but it doesn't need to be super well researched unless it's a dream role. You can take a few things like from the website, the mission statement, see what things you align on, put those in your cover letter, and make sure you put it in the job applications. I recently saw a post, if I could find it afterwards, I'll link it, but how to use ChatGPT to kind of tailor your resume. Tailoring your resume per role has been done, since people started working in tech. But I think the most common thing that people do is you see the job description. First, see that you meet at least 50% of the criteria. I say if you meet at least 50% and it's one of those quick applications, and it will take you maybe 15 minutes to submit an application or less, just apply for it. See how they phrase their requirements, like what they're trying to get from the requirements, and then retailor your resume for that. Remember, just one page, no CVs. And if you have something that fits more into a requirement, maybe just, take off some of like the competition, some of the extra projects, just to make sure that your resume is tailored. A lot of these, if we're applying for roles as a machine learning engineer and we know that our resume is likely going to go through some kind of algorithm, we got to fine tune the algorithm. We know how to do this. And so we should use our skills to do that and to give us the best possible outcome. Looks like we got a question about networking. That's a great question. So the next area we have is actually on networking. So we just covered, it's a numbers game. So give yourself the best advantage, put in as many, just give yourself a goal. Maybe I'm applying, 3 or 4 times a day, or like 3 or 4 applications a day, Monday through Friday. I would personally say do at least 5 applications a day, but don't spend more than an hour on a single application. That's not necessary. All right. So rule number 2, network. So sending out cold applications where you have no connection at the company, it's not going to give you the best ROI, return on investment, for the amount of applications you send out. What you really want is that warm introduction where you know someone at the company. And yes, I know that's ideal, but you can start networking today. I've talked to a lot of folks who are PhD students and they're like, oh, well, I'm going to be in this role for the next 5 years. Just start networking. There's so many folks that are just on this recording. You can connect with me on LinkedIn. You can connect with all the speakers, send them an invite, send them a message that, you appreciated their talk, you'd like to connect, because those connections really build up over time. So if you're able to just set a goal for yourself of like, I'm going to attend 1 in-person meetup a month, and I'm going to attend 4 virtual meetups every month. So like 1 a week, attending those sessions, making those connections, just really build up over time. And the key thing like with that network as well is it just keeps expanding. So being able to connect with individuals, you'll see that while tech seems very large, you'll be seeing the same people over and over again. And you'll be like, if you had a great experience with them, you'll want to work with them again. They may want to work with you. You may even, work together on a startup. So there's a lot of options there, but just putting yourself out there. And that tends to be the hardest part for a lot of people. Like they'll crush coding interviews and they'll crush system designs, but putting themselves outside their comfort zone, introducing themselves, asking people what they think of, what do you think of the company you're at? I'm considering applying. Doing that can be hard, especially if it's fully remote and fully virtual. But, just do that. And I even in my post put out a few kind of like just example wordings that you can use to connect with people on LinkedIn. For me, networking is primarily through LinkedIn. Like if someone writes a great blog post, like I'll message them, wanting to connect, like wanting to follow the work that they're doing, meet someone at a conference, like wanting to connect. And so just kind of making it personal, making it tailored, and just building up those connections. And the more connections you build up, the more mutual connections you'll have. And especially if these are the roles that you're looking to get into, the more connections you have around that field, the better populated your LinkedIn will be with new roles, research coming out, papers. Like I love going on LinkedIn because I have such great content to consume. So just keeping in mind, building that network just really helps you become the best machine learning engineer, data scientist, MLOps professional that you want. So let's go into some of the questions here. So I think I answered kind of the best ways to network. A lot of community events. Also, if you're looking for roles, there's different channels that you can look in. CHIPS, MLOps Discord channel for jobs, in the MLOps Slack group, and Data Talks Club. So there's a lot of different Slacks where everyone is kind of on the same page. There are different channels you can join, and just messaging people through Slack and Discord is a great way to connect. All right, so question from Calvin. So one of the issues that you've been experiencing recently is sending out a lot of applications. Okay, getting some interviews, that's great. Already getting some interviews back, but there aren't as many companies hiring as before. And then you're probably like applying for jobs that might be continuously listed and maybe they don't take them off. So any thoughts on the current job market? Wow, that like perfectly kind of segues into the next topic. So thank you for that one, Calvin. If it's never the right time, it's always the right time. So I've heard over and over, pretty much this year, like we've seen a lot of tech layoffs. But if you look back to essentially since the dot-com bubble bursting, there's been, never like 3 or 4 great consecutive years to get a job in tech. And when people say like, oh, it's the wrong time to graduate or the wrong time to look for the next role, you kind of just have to look back and see, well, the pandemic and then recessions and then, just different parts throughout. And obviously this is tailored to the US economy, but just looking back through different markets, and you can check the economy for your own country, but it's going to probably look similar. The only thing that is consistent though is the growth of jobs in tech year over year. And the amount of people hired for emerging technology. So that's what tends to be the thing that separates tech, is that it's constantly turning over, but it's more just pivoting. So the pivot comes from tech being so new. Like I myself have had, if you look at my LinkedIn and the roles that I've had such a variety of roles in the past like 4 or 5 years. And that's also what really made me want to be in tech, coming from academia. Folks here that are in the chat coming from academia, you've probably experienced this too, where if you're coming from academia, you're kind of prided on being very, very specific and staying with that for a long time. And that wasn't really conducive to like the way I learn and what I wanted to experience. I wanted to try a lot of new roles. And for tech, constantly changing to a different environment, you need to learn a new set of skills. I would say we have shifted away from the folks because I would say around 2018, a lot of folks were able to get jobs as data scientists without a boot camp, without a degree in data science, and with only experience in the Jupyter Notebook. But now we're in this phase of MLOps and even large language models where you really have to think about infrastructure and think about scalability and be able to handle dirty data. So we've seen that. I'm sure you've seen that, like with folks kind of getting new roles, going through the job interviewing process. There's just more to it than there was a few years ago, and just the names of titles are shifting and shifting. Calvin, you mentioned going from data scientist to machine learning engineer. That is the direction a lot of companies are taking, wanting their data scientists to be a bit more engineering heavy and being able to handle engineering situations. So in terms of my thought on the current job market, you could still go to LinkedIn. Actually, my favorite thing to recommend to folks looking for new roles is go to LinkedIn, look at jobs, filter by the most recent jobs. If you have something like remote, that's a requirement, or you want to work in a certain city, put all those options on and you can see like the latest posted ones. Going from company to company, if you just think, oh, I'm interested in this company, and looking at those job roles, there's a chance that those are outdated or they're not a priority. So going and seeing the latest posted jobs, like if they posted that 3 hours ago, I bet they're still hiring for it. And that's what I tend to find. And in terms of the job market, what we're still seeing is still a lot of data science roles, but what's the word I'm looking for? Like the uptake, just like the acceleration increase for data science roles is slowing down. Machine learning engineers, software engineers, data engineers, those are still really high. But now we're seeing things like big data, MLOps, DevOps, infrastructure. So just keeping that in mind, you can make your search pretty broad for areas of tech, and then you can see the different job descriptions. Because once you start looking at 10, 20 job descriptions in roles you would like, you might see that there are slight differences to the job market a few years ago. And so that's really where it's changing a lot. Chip session, they go into like the most current trends for MLOps and what ML engineers are expected to know. So definitely check out that panel. Okay, let me see here. All right, let me go back to comments, just navigating a few screens here. Okay. Also, thanks, Maggie, for putting in that there's a great networking event tonight in the Bay Area. Just this entire Arize event is a huge networking opportunity. So check our Slack out, join our Arize Slack, join our community, see who's putting in their introductions and their introductions channels, because there's so many people there that would make great coworkers, great managers, and just say hi. So our introductions channel is really blowing up right now from everyone that's participating in Observe. So there's obviously a lot of speakers there, but a lot of attendees and companies who are hiring. So going into introduction channels and Slacks is also a great way just to say hi, meet someone. And if you notice a lot of things in common, just comment on that. Like, oh, same background, same university, like notice those commonalities. So Maggie's putting in the links for some of the networking sessions within the platform, the Slack, and just so you know, like we do have courses as well, and you can connect with people who have taken those courses. So just another possible networking opportunity. We have 2 courses, the introductory and the advanced course. All right, back to some questions here. Let me adjust my camera, make sure I'm kind of in the middle. I have a tendency to just kind of lay back. So I want to make sure everyone can see me. All right. All right, next question we have about reaching out to people on LinkedIn or doing informal interviews. informational interviews. So interesting thing about like reaching out to people on LinkedIn, interviews. So I showed a few options, and I'll reshare my screen still sharing. Maggie, can you see my screen? Oh, perfect. Okay. I see how it works. Yeah. So a few like options for what to send to folks on LinkedIn. Great way to connect. And then one of the last things I want to talk about is everything's an interview. So we pretty much covered how many applications to send in, continuously networking with folks, and then the job market is constantly changing. But the amount of open positions, time to fill those positions is it's increasing year over year. Just the amount of roles in tech are increasing year over year, and the titles are changing slightly, mostly because the skill sets required are changing slightly. And while we are seeing, large tech layoffs, I've talked to a lot of hiring managers and folks in the industry, and what we see is it's kind of a correction to a bit of an overhiring in the market several years ago. But those companies are still hiring. They're still hiring backend. They're still hiring project managers. There's a lot of times still hiring entry and senior, not as much in the mid-level, just for what I've been noticing in the market and what I've been talking to people about. But these kind of informal interviews. So everything is an interview, and when it may sound kind of scary when I say everything's an interview, but it is. If you meet someone at a networking event and they're hiring, and you mention you're looking, their thoughts are automatically, "Can I hire this person? Would this person make a good coworker?" And it's not to scare you off, because the number one thing interviewers, like when you start a technical interviewer, the number one thing they're looking for is also, can I hire this person? No, like the interviewer is always on your side. So, they want to help you. And so just having, just reaching out on LinkedIn, asking for 10 minutes of their time, like, maybe they have that career projection. That's the exact same career projection that you're hoping to get into. Maybe it's your dream role at a company and you just want to kind of pick their brain to go through their experience, because I guarantee you they have advice. And if they do have the time, they're probably willing to hop on a 15-minute Zoom call just to kind of meet with you, go through a few things. And if they know they're hiring, it's beneficial to them, because if it's a great call, in those 15 minutes, they could be getting a new person on their team that will help them with their workload. They might even just introduce your resume internally. Maybe they get a referral bonus. And, if they think that maybe you're not the right fit for the role, they've still made a new connection. They've built out their network. So it's normally a win-win when you have these short conversations. And the worst thing they're going to say is no, but they'll probably still connect with you. You'll still be able to kind of follow along and see if there's like any new material they're putting out. Okay. Let's go back to some questions here. Next question. The pace at which the industry is evolving is so fast, and the job of an MLE or data scientist is changing really quickly. How do I know what skills to focus on? That's a great question. Those will be talked about in a CHIPS panel in the career session. But I think for like a lot of the skills, first it's figuring out like what role you really want. So I recommend going through a lot of different job applications. Like maybe you do want a data scientist role, maybe you do want a machine learning engineering role or a data engineering role, or maybe you do better as a technical project manager or a product manager, or a similar role. So look at those descriptions, see what the requirements are, and think, if you don't have that skill, like, is that something you'd want to learn, want to get involved with? Because really, it's the job descriptions that are going to tell you the most important skills to focus on. But for machine learning engineers, it's no longer enough just to kind of create a linear regression model or, retrain a neural network. You have to think about, how would I get the data So starting with the data, how would I train this model? How might I continuously retrain this model? How am I going to deploy it? And then how am I going to monitor it in production? Because it's not enough just to build the model now. You really have to see how it's doing in production, and being able to say, my model is improving business outcomes by X amount, and putting business metrics and KPIs with your model as well. Okay, we got some new comments here. Let's see. So Dat asked about prompt engineering. Do you see this as a bigger role in the future? I'm actually going to link my post to I think it's the 3 main steps to prompt engineering. I do think it's becoming larger. Now there's, courses on how to become a prompt engineer, but it's really something that, we're just going to have to wait and see. But there's already been a few roles, which is more than there were last year. So I think it is picking up, but we'll see. I think it could go either way of being like the biggest role or kind of fading out or kind of merging into machine learning engineering roles. Garrett asks, so before time is up, if I can expand on everything as an interview. And then he is sharing a experience here that he hopes relates to other people. I've had a lot of people who could recommend me, but none of them are hiring. That is very common. How can I get them to speak with the hiring managers and teams before I submit an application? That's a great question. And it's a great way to also have them keep you in mind as soon as they start the hiring process, because sometimes teams aren't hiring and then, it's 3 weeks later and they have 2 roles that they're hiring for. So keeping that resume, and that's why a lot of times you might see a role on a company's site that you apply for, and then they say like, oh, we're not hiring for it right now. They're collecting those resumes because they're about to start hiring for that. And what you can do, Garrett, is just reach out on LinkedIn, send a short message. I would say tailor these message more towards people on LinkedIn than you do when you tailor your cover letters. Because when I get a message that, mentions, I read your blog post, or I love like the work you're doing, or I saw this talk, when someone is making the effort and I see like oh, they actually, know what I do, they know who I am, they're interested in what I had to say. I'll get on a 10 or 15 minute call. And I do this all the time, getting on these 10 or 15 minute calls just to speak with them, because, that is an interview. And you can ask like, hey, like I saw this job description, I have this experience. Do you have any thoughts on that? They may or may not, but a lot of times if the conversation goes really well, if they could see you at that position, they'll offer to send and introduce the resume internally. And we know internal introductions have, I think it's about a 10 to 30% return rate on getting at least that first call scheduled, compared to like a 1 to 3% return rate on a cold application. So an order of magnitude better in terms of getting through that first round. And also, the more connections you build, the easier it is for folks to find you on LinkedIn, like hiring managers and recruiters. And so you'll be getting more of those types of messages. All right, everyone, I think we're out of time, but I will be answering more questions in the community chat. So I'm there all the time. And yeah, thanks everyone. I hope you have a great day. Bye.